Welcome, everybody, to episode 9 of our AI in e-mobility series. This is the final episode for this mini-series, and it's exciting because this is the part that will close the loop in our circular economy picture. Over the past weeks, we have talked about lots of AI use cases along the various stages in the battery value chain, from design and development to battery testing and manufacturing, and then, for example, even EV charging. And now we're ending the whole story with the battery recycling area. And I'm super excited to have Paul-Miki Akpablie with us today, who is the founder of a startup called Sankofa. Paul-Miki has an incredible background with an MBA from Stanford. He has definitely an entrepreneurial mindset. He has started several companies, also scaled up a battery manufacturing plant in Ghana. And his latest startup, Sankofa, is an AI-empowered software for sales and operations planning, as well as execution in the area of battery manufacturing and then also recycling. You have this tool, and this is now my current understanding, in your recycling facility. It will be very easy for you to forecast recycling needs, manage your incoming goods, such as either end-of-life batteries or scrap materials, optimize your internal processes in terms of yield performance and efficiency, as well as selling off your output materials at the right time, be it black mass or really the raw materials. Thank you so much for joining us today, Paul-Miki, and welcome.
Thank you. Yeah, so happy to be here today.
Maybe can we start out by you telling us a little bit about yourself, your background, and then, of course, we start talking about your startup.
Like you mentioned, my name is Paul-Miki Akpablie. I'm originally born and raised in Ghana, West Africa, and I've had the chance to live in Hong Kong and then the US. And I came to the US for school and then ended up staying here. Just super passionate about building companies that truly make the world a better place. And so I'm never scared to always go after complex problems and just love being a founder. Have founded different startups in the past, and like you mentioned, one in the battery manufacturing space. And given where we are today, I just think recycling is the biggest missing piece in our decarbonization efforts. And so, started Sankofa to address that problem.
You mentioned that you like picking complex challenges. You definitely picked yourself one here.
Yep.
First of all, where does the name Sankofa come from? And then in a nutshell, and we'll talk about the details later, what is it? And also what role does AI play in all that?
Yeah, so Sankofa is from a Ghanaian language called Tree, and it basically means go back and take it. Or to simplify that, it basically means looking backwards to inform the future. And that's very fitting for what we're building with battery recycling, because we feel like the industry has gone through so much transition, and we have a unique opportunity to build a future much more along the lines of closed loop versus the linear model that has been done for several years. And so at high level, what we're building at Sankofa is basically an AI-powered system that enable battery manufacturers and recyclers to plan, forecast, replenish, and recycle battery materials in real time. We just haven't seen supply chain infrastructure built for this industry, and we have the unique opportunity to make it easier for cell makers and recyclers to reuse old batteries to make new ones. That's the future that I think we're all hoping for.
Well, thank you so much. And before we kind of dive into all the technical aspects and what you're doing with Sankofa, I'd love to learn more about how AI kind of influences your personal life. We've seen how it shapes businesses, but as with every other episode, I'm very curious to see how it impacts you personally.
AI has been very transformational for me personally. And in my day-to-day, it's a lot of just using ChatGPT to, proofread stuff that I put out there. And also I'm learning more and more about AI in customer service support. And so, I've been interacting with a lot of systems that sounds like human, but I'm guessing they are not. And just the ability for them to answer questions and get me to the right resources within a few minutes is quite intriguing. And also living in the Bay Area. So I was one of the first people who got off the wait list for Waymo. So just, stepping in a self-driving car and watching it navigate all of these roads and signs and stuff like that has been very inspirational. And yeah, so I'm just super excited, and I think AI is here to stay, and super excited about the future.
And I realized throughout all my interviews that everybody has a little bit of a different definition of what artificial intelligence really means to them. So maybe
Mhm.
can you just define what is AI for you?
I mean, a lot of people will say like, machine intelligence, but for me, AI is about building systems that take over tasks and stuff that for us humans have little to no utility. And so that's my definition of AI, that there are so many things that as humans we do in our day to day that just takes so much of our time, be it, back office, be it like day to day stuff that I feel like the promise and my definition of AI is, yeah, building systems that automate a lot of those repetitive processes that have little to no utility. So we as humans can turn on more of our creative hearts.
When did you personally get into AI and why and where do you learn about it and how do you stay informed?
Yeah, that's a great question. So, yeah, I've been in the industry for quite a while. My undergrad was actually in in math, and I took a class called probability theory, and that kind of opened my mind. And this was like 2012, 2013. But looking at Bayesian theory, looking at all of this different theories in probability, which are now a lot of the foundation for AI systems. So that's kind of how I got into it. I got so excited, and a lot of the research projects I did was around that, clock reactions in chemistry and trying to simulate all of that. And it's so interesting to do that in college when only a few people were talking about like AI in 2012, and now to see it all coming together and then to dig deeper into it and realize that all of those different like Gaussian theory, like all of these things that I was learning is actually the foundation of AI is super cool, and really fascinated by a lot of what other people have been able to build with that kind of knowledge.
It's very nice to hear because I think there are lots of students and people out there who might think, when will I ever need what I actually studied? So in
Yeah,
your case, you're
yeah.
now coming back to all this. This is wonderful. So let's now dive into the details of what Sankofa is doing. And I
Mhm,
think before we even start talking about the recycling part of what you do, I would
mhm,
like to kind of lay out the foundation of what we're speaking about, and
mhm,
that requires talking about the entire supply chain for EV
mhm,
batteries. So, can you give us some insights into the supply chain for the battery industry in general? How is it managed between all those different stakeholders? And also, how is it different or how does it compare to other automotive supply chains?
So, the battery industry has gone through so much evolution. Um, like 20 years ago, only a few players really dominated the market. And so you have these big players that are managing, basically making cathode, anode, basically all the different parts of the battery. And then fast forward, we've seen so much innovation and development in the landscape that now, instead of taking all of that risk in-house, you are outsourcing a lot of these different parts. So there are now companies making the cathode, people making the anode, people making the electrolyte. And so when it has moved from a very vertically integrated industry to now very scattered with so many different players that need to plug into making a battery, that's where a lot of the complication arise, because now it's almost like you form this orchestra, right? And you need a system, a conductor that will make sure all of those plans and everything are executed in a timely manner. And that's why before, players can get away with using your traditional ERP systems because, yeah, you're managing everything and it's easy to put in transactions and get things going. But now you're not only at the mercy of your internal systems, but like other players within the industry. And that's where a lot of the complication comes, because even I've heard stories, even with one supply delaying, that could set back your production timeline by a year, 2 years, or even more. And so that's kind of in a nutshell how the battery supply chain is engineered. But on the more, I guess, nerdy side, battery is very special because it has two different type of manufacturing. There is the discrete manufacturing, which basically means that different players make different components, and then which is very typical in the EV industry. Then you put it all together. But parts of the battery, like electrolytes and some of that, goes through process manufacturing. And so battery is one of those unique things where it has both type of manufacturing
Oh, that's
techniques.
interesting.
Yeah, and so what we've seen and where I think the industry is going is that when you have this globalized and suppliers across different geographies, you need an effective way to bring all of them together. And that is exactly where the industry is right now. And that's why I always say battery supply chain is one of the most complicated supply chain systems in the world, and one that, if not managed well, like leads to a lot of losses and set us back in our decarbonization efforts.
You mentioned already some of the challenges or complications like geography, then the discrete versus process manufacturing, and then there is such a large variety of different players. So can you summarize a little bit of the challenges? And
Yeah.
then of course we need to understand how does your startup help in all that?
Yeah. So let me start by saying one of the biggest challenge with the battery industry is that we haven't built a closed loop infrastructure. And that's scary for a lot of young people like myself, because if we don't figure out how to use old battery parts to make new ones, I think we are failing ourselves and we are failing the planet. And so that is one of the biggest gap that I see today. And there's stats to validate that. In the US, less than 5% of old battery parts end up in new battery. Let that sink in. That's very staggering. So that's the first thing that I was saying. The second thing is, if you look at a lot of the demand for EV, electronic products and everything, we don't have enough time to build new mines. And I think the whole notion that every time we need to make a battery to decarbonize, we have to go to places like Africa, places like Latin America to build new mines, to dig into the ground, and in most cases even destroy some of these lands is really frustrating to a lot of young people globally. So those are the big challenges, and which is why trying to figure out how can we increase or put a lot of old battery parts into the supply chain is better for the planet, is better for everyone involved. It's cheaper for a lot of players because you can get that from San Francisco, from within the US, or from wherever you are, because batteries are essentially everywhere these days. And I think it's just a no-brainer.
And I think that's a very important thing of you to point out that the circular economy and this picture that I've shared throughout this whole series, we're not there yet. This is not created like this yet. There's lots of efforts and programs put in place, be it in the US or in Europe, but it's really not realized to the full potential. How does a tool like Sankofa kind of help here? And like you said, you're also kind of approaching this from two ends, closing the loop. Your software is used at the battery manufacturing facilities,
Mhm.
even like the actual anode and cathode material companies. So really at
Yeah.
the start of the value chain. And then also the end in the recycling facilities. So what does it do?
Yeah. So, like what we shared earlier, supply chain for a lot of these systems used to be linear. In a lot of sense, it still is. Take, make, and just throw it away. That's kind of the system that has been built for years. And so a lot of the tools like ERP and existing supply chain infrastructures are built around that notion. Take, make, and then figure out what to do with it once it reaches the end of life. And we see a unique opportunity today where we can build a different kind of supply chain tool that has a lot of closed loop manufacturing and recycling embedded in it. And so we believe the gap is building like advanced systems that are able to, one, understand how complex batteries are, understand what are all the different players involved, and give a lot of supply chain managers and business leaders the decision support that they need to see the value in using recycled materials, and two, to also save cost. Because if you can use or recycle a cathode to make a new one, that saves you a lot of money. And really, the idea is that we can help cell makers and battery recyclers better forecast battery returns. That's a very, very complex problem. And the second one is basically creating a whole cell cycle and planning around all the byproducts of this recycling process is very critical, because you need to understand all the different components that are in that battery and figure out, okay, if I get this end of life battery, what are the quantity or volume of different components that I can get from it? And that type of modeling is really, really hard to, given how fragmented different battery chemistries and it's just very complex. And the third layer, and another problem we're trying to solve, is the future of battery recycling only makes sense when it's one, good for the environment, and two, is profitable, right? And so the whole market is very nascent. Black mass pricing is very just offline. You just negotiate and figure out, who wants to pay what. And so the third layer is building market support tools that enable these recyclers and OEMs to figure out, should I be buying recycled components at this moment? Should I be buying end-of-life batteries? Should I be recycling? And if I recycle, what percentage of that should I be feeding into my internal demand for these materials? And what portion of that should I be selling in the open market? And we think that if we nail those three layers, the future of closed-loop battery manufacturing is promising once those three layers have been nailed, and that's the journey we are on.
That's super, super interesting. I would like to get a little bit more concrete now. So let's say specifically for a battery recycling facility, you mentioned that a typical ERP tool, an ERP, for those that don't know, stands for Enterprise Resource Planning. Those tools are kind of made for linear economies. So
Yep.
It doesn't really work for battery recycling, as we want to be circular. But how there's a couple EV battery recyclers that exist today, like Redwood Materials, Li-Cycle, and all that. So how are those guys managing supply and demand today? What's kind of the best practice?
Yeah. So when you look at a lot of what industry players are doing today, which is very scary, Redwood Material and a lot of the big guys, it's a guessing game. So they're basically hoarding, they're taking whatever they can get. And that's good when you have funding from the government, which Redwood Material does have. But at a certain scale, that begins to fail, right? And so with building this tool, we can put a lot of strategy and a lot of decision support on what different battery chemistry should you be investing in? What can you get from it? You also have to think about warehouse cost and compliance. You just can't keep end-of-life battery living in a warehouse. That's a fire hazard. So these are all things that a lot of leaders need to think about that are not built in our current ERP systems. The current ERP systems are built for transaction tracking. And so in that system, it knows what a battery is, and it knows what the raw materials involved in are. And that's it. And so building systems that can break down from the battery all the way down to raw material and all the intermediates, cathode, anode, electrolyte, alloys, like all of this stuff is really important, and stuff that hasn't been built in a lot of the tools that we've seen today. And even things around lot tracking. One thing that we envision is that compliance for battery recycling is going to get even more and more complicated, right? Governments are going to require that, okay, who recycled that battery? Where was it located? You need to provide all of this information. And these are all things that are not built in like the traditional ERP system. And we have the ability to build a whole different kind of system. And that's why we're really excited for this.
For a battery recycler, what are kind of some key metrics that the tool is kind of including? Can we talk about some real quantities, some numbers and use cases so we can get a better understanding?
Yeah, so our tool is more applicable to battery recyclers with some type of existing operations. And so when we are looking at across the operation, we're looking at recovery rates, right? Looking at historic recovery rates for the end of life batteries. We're also looking at yield percentage. We're looking at target safety stock. Do they have enough battery in their safety stock to meet whatever demand or partnership they have with the OEMs or the manufacturers? And also things like forecast, being able to see how much they should be taking in to feed their demand on the other side, right? And so these are all things that today it's a lot of Excel tracking that is just so inefficient. But I think an even bigger opportunity for recyclers out there is the ones that are new. That if you can create that data discipline that at the early stage of like building your recycling plant, you have the best tools in your toolbox. I think that's how you build profitable and scalable business.
Yes, I really love the phrase building up this data discipline. I like that. And I think it only makes sense if, all of those different stakeholders actually come in into one environment, because only then can you really make this happen. Now, data is one thing. How does AI come into all of this?
Yeah. So we're still on that journey. AI is always an evolving thing. But yeah, like I said, the first step is all about data discipline. The battery industry is very complex, different battery chemistries, different suppliers around different geographies, different regulatory risk, new laws, new requirements coming every year. Um, and so when you look at a system like that, with even battery data is not like a very publicly available information. You can look at shipment logs and you know whose battery is coming from where, but the actual components and actual chemistry, a lot of battery makers like to keep that close to their chest. And so when you have some of those challenges, obviously building AI systems is very difficult. And so what we've done and why we're really the only player trying to build a different supply chain tech infrastructure for batteries is really tapping into their planning and forecasting system. So starting from the top and figuring out based on our experience, like we shared, like I had a battery manufacturing startup, so I'm like a battery manufacturing SME. And I also have someone on my team who's worked at Ford, Johnson Controls, so also has background in battery supply chain. I would think those ingredients are what you need to build AI systems, because it's wishful thinking to just say, oh, AI is just like, oh, I don't have any expertise in this industry, but let me just put some data through and it's going to create the kind of insight that I need. No, you need leaders who understand what are the complexities that the industry is facing and what is the desired output. And for us, the desired output here, if we can give cell makers and recyclers complex decision support system that's not available to them today, I think that's the big win. And the other layer is just like simplicity, right? Making it, because traditional supply chain systems and giving like the nature of the battery industry, data is very complex. It comes in different shape and form. And so a lot of our AI application involves how do we take this data and train our models to then create all the insights that these leaders need, and also give them the capability to simulate in real time how certain changes to their sourcing and recycling strategy impacts their bottom line.
That's lots of opportunity to make the right decision using a tool like this. And I'm very excited to see where it goes once you roll this out with more and more companies. So in our last part of the podcast, I would just like to talk a little bit about the future of our industry. With all the high craziness going on, some of it is hype, but as hopefully presented within this mini-series, there is lots of real use cases and really lots of amazing approaches that we're taking here. So how do you see our industry kind of develop with more and more AI being used everywhere? What's your thoughts on that?
Yeah, I think it's at an inflection point. I think, I live in the Bay Area and a lot of the use cases for AI here, I think are great in the short term. But I think AI is such a powerful tool that, given my background, I'm just super excited about using that technology to like solve really complex problems. And battery supply chain is one of them, right? And so when I think about the future, I think one, recycling is a big one. Battery recycling is a big one because it's a no-brainer, and we can see a future where it's easy to throw away plastic, but if you throw away battery, it's like it's there and it's a fire hazard and all the things that come with it. So that's where we see the biggest opportunity. But like what we've said earlier, and we see a lot of opportunity in the manufacturing space. So quality control measures and really decreasing the amount of waste that battery manufacturing generates. And also, I'm just super excited about new technologies that are working much more on the end of life battery logistics infrastructure. So I've seen people building cool stuff that you put the battery in it before you transport it. Because UPS and these guys, they're worried about transporting end of life battery. It's a fire risk, right? If we
Yes.
can build systems that reverse that, it makes it easier for us to move those to the right processing facility. So that's areas that I'm super excited about. And outside of the whole battery manufacturing, I'm also excited about the whole advanced manufacturing space, semiconductors, defense tech. Like these are all systems that on manufacturing within these sectors now have robotics, AI, automation. And so, unlike in the past, a lot of the data that we're getting out today is very complex data, and it's hard for a human to take an Excel and make sense out of this data, right? And so building systems that ingest this complex data and turn it into easy decision insights. Hey, logging into the system if you're a planner or whoever and be like, hey, Veronika, these are three things you need to do today. Imagine how beautiful that would be. That, hey, I need to put in this order, do this, do that. That's
Yes.
my, day-to-day task. And that's the future that we envision within the advanced manufacturing space. I have some background in healthcare, and healthcare is a sector that I'm super excited about. AI in, medicine from surgery. There's a lot of opportunity there. I used to work in kidney dialysis where, parents generate like a lot of data every time they sit in their chair, potassium, like all of this, and systems that can even prevent some of these patients from ending up in the hospital is huge, right? And you can also think about the financial sector, right? Putting a lot of people's money to work, cybersecurity, like all of these things, like I'm just super excited about AI. And I always just encourage entrepreneurs that AI is such a powerful technology. And my only hope and encouragement is that we use that for not just because it's AI, but like use it to solve fundamental problems. And so I personally don't like to use the word use case. I prefer problem case. So using AI to solve a problem case, right? Look at what the world needs, what some of these companies need, right? Figure out their core problem and see if AI can more effectively address that problem. And I think if a lot of leaders and a lot of entrepreneurs are thinking like that, AI will find its way in tackling more complicated problems than what we see today, which is a lot of chatbot, a lot of, customer
Yes.
service automation. There's just so much complex problem that we just have to take a leap of faith and really figure out how do we address those problems.
Love that. And I think this was really a wonderful closing of
Yeah.
our episode. So, Paul-Miki, thank you really so much for joining today and sharing all your very interesting insights. This has been a great end of our AI in e-mobility series. I just really wanted to cover all the different aspects, and I'm sure we didn't cover all of them, but a few of them along the battery value chain, and today really kind of close the loop. So, yeah, thank you for listening and see you
Thank
soon.
you.